Greetings, class. This is Dr. York-Hammons. We're still looking at Chapter 8, Section 1, testing the difference between two means, given the population standard deviation for each of the samples, and that the samples have to be independent. So we're on page 425 of the e-text. I've copied the information and the problem, so I thought it would be nice to have one where they didn't just give you straight out the data. You had to pull it from the problem. And this one also asks us to find the rejection region. So part A says identify the claim and state H sub O and H sub A. Find the critical values and identify the rejection regions. Find the standardized test statistic Z. Decide whether to reject or fail to reject the null hypothesis, and then interpret the decision in context of the original claim. Now, the nice thing they're saying is assume the samples are random, independent, and that the population is normally distributed. Those are the conditions under which we're able to run the two-sample Z test for hypothesis differences. So let's look at the problem about meal replacement diets. To compare the amount spent in the first 3 months by clients of two meal replacement diets, a researcher randomly selects 20 clients of each diet. The mean amount spent for diet A is $643. Assume the population standard deviation is $89. The mean amount spent for diet B is $588. Assume the population standard deviation is $75. At alpha equals 0.01, now that's a 1% level of significance, can the researcher support the claim that the mean amount spent in the first 3 months by clients of diet A is greater than the mean amount spent in the first 3 months by clients of diet A? So we're actually going to let sample 1 refer to diet A, and we'll let sample 2 refer to diet B. So the claim is that the mean for the population mean for sample 1 is greater than the population mean for sample 2. So we need to consider that this symbol, greater than, does not have the equality symbol. So this must be H sub A, the alternative hypothesis. So we can actually write H sub A as mu1 greater than mu2. But we also need the null hypothesis, H sub O. Now, H sub O has to be the complement of this inequality, and if H sub A is greater than, then H sub O must be less than or equal. So now we have the null hypothesis being mu1 less than or equal to mu2, and the alternative hypothesis as mu1 greater than mu2. Now, as we read through the problem, we could create a little table to actually outline the information that we have for each of these. So for sample 1, which is diet A, we know that the sample mean is, the mean amount spent for diet A is $643. For sample 2, which is diet B, we know that the sample mean for diet B, the mean amount spent for diet B is 588. Now we also need to know the population standard deviation for each. So for diet A, it says assume the population standard deviation is $89. So that's 89. Then for diet B, it says assume the population standard deviation is $75. And then we also need to know the sample size. It says he selects 20 clients for each diet. So our N1 is 20 and our N2 is 20. And it says our value for alpha, our level of significance, is 0.01. And then you'll remember when we do our interpretation that alpha could also be a percent. That would be a 1% level of significance, and that's a pretty tight level right there. So before we go on to using StatCrunch, I'd like to do a reminder about that in StatCrunch. These are typically written as a difference between the two. So where you see it in the form here, in StatCrunch, when you do this, it's actually going to take this mu1, or mu2, excuse me, and it's going to subtract it from the mu1 minus mu2, and that would be less than or equal to 0. So for the claim, you would see this in StatCrunch, where we would subtract the mu2. I'm going to come over here and subtract the mu2. That would be greater than 0. Maybe I'll make this a little bit bigger font so that you can see a little bit better what we're looking at here. And so this is still our H sub O and our H sub A. And remember again, this one is our claim, is that the diet A costs more than the diet B on average. So let's take this and look at StatCrunch, taking the information from our table. So we're in StatCrunch. We're going to stat. We are doing a Z-stat, but this time it's a 2 sample, still with summary. Now, for sample 1, I've typed this in the order that you would see it in StatCrunch, the sample mean, the population standard deviation, and the sample size. So the values we put in StatCrunch for sample 1 are 643, 89, and 20. Then for sample 2, same order, sample mean, population standard deviation, and sample size. So that's 588. The standard deviation is 75, and the sample size again was 20. Now our hypothesis test in StatCrunch is going to look like the inequalities here. Now we can't change the one for H sub O. That's always going to look like equal. But we can change the one for the alternative hypothesis, and we need to change that to a greater than. Mu1 minus mu2 greater than 0. So let's do the drop down list, change it to greater than, and then I want to store this in the output, the data in the store the output in our data table. So when I do that, and I'm just going to hide the options window, you can see that your Z-stat, the Z-test statistic, is 2.1133, and the p-value is 0.01728. However, our problem asked us to find the critical values and the rejection region. So since this is a greater than at the 1% level, to find the rejection regions, you go to Stat, Calculator, and normal, leaving it at a mean of 0 and a standard deviation of 1. This is a greater than, so I want to be sure that I'm doing the greater than. On the testing side, I'll be on the right-hand side with a greater than. I have to do greater than or equal because that's the only option in StatCrunch. And my percentage that I use is the one that goes with alpha, 0.01. So when I compute that, it shows that my value has to be 2.326. So for my rejection region, I guess I should do the the critical value of Z is 2.326 to 3 decimal places. So the rejection region is is our Z test statistic greater than 2.326. Now it has to be greater than because that's the same direction as your alternative hypothesis, greater than. And you'll notice that this red region here for greater than is bigger than, it's on the right hand side, so it has to be greater than that 2.326. So we look and we say, we look back, I'm going to close this window, and our Z test statistic, now this is our test statistic that we found for Z, and you have to ask yourself, is 2.113 greater than 2.326? And the answer is no. So our 2.113 is not in the rejection region. It's not in that red area, so we would fail to reject H sub O. So if the answer is no, we're not in the rejection region, we would fail to reject H sub O. Now, that's with the rejection region, and we have to interpret the decision. Since the claim was our alternative hypothesis, and we did not reject the null, we don't have any evidence to support that claim. So you would say that there is not enough evidence at the 1% significance level to support the claim. Now, if you looked at the p-value, this is just an aside because it didn't ask you to use the p-value, but I'm just going to let you know, if you looked at the p-value, p is 0.017. and alpha was 0.01. In this case, our p-value, and this is just an aside, the p-value of 0.017 is greater than 0.01, which was our value for alpha. So again, fail to reject H sub O. Either way you looked at it, we would fail to reject the null hypothesis. But the rejection region, just as a reminder, I'm going to bring this up in the couple of seconds I have left on this particular video from the normal calculator. When we did the calculator, the rejection region was where we were greater than, our test statistic would be greater than 2.326. And we were not over here in this area. So we failed to reject. The critical value was not in the rejection region. And again, the p-value supports that, fail to reject because our p-value is greater than alpha. So both ways we fail to reject. I hope this helps you work through section 8.1.